We're given a 3-year temporary life annuity due of 100 on age 75. The integral from 0 to x of the force of mortality is 0.01 times x to the 1.2 power. We're given 11% interest rate and want to calculate the expected present value of this annuity. So let's look at the first bullet point. If we look at e to the negative integral from 0 to x mu t dt, that's the same thing as starting at age 0 and calculating the probability that it will survive x years. But what we want to do is get it in the form of age x surviving t years, because we're looking at an annuity due for 3 years. So that's going to look something like this. So that's just 1 plus v times the probability of surviving age 75 plus v squared times probability of surviving 2 years. So clearly you can see that we have 75 and we don't have 0. So x here is going to play the role of 75. Okay. So the way we're going to do this is we're going to go from e to the negative x to x plus t of mu t dt, which is really the same thing as going from e to the negative 0 x plus t mu t dt. Okay, and then we're going to subtract, going from the integral from 0 to x mu t dt. So there's a reason I'm going from 0 to x plus t and 0 to x, because the way the integral is given here is you have to start at age 0. So that's just, well, we just plug this in for x here. So here it's going to be x plus t in for x. And then the second integral is just what we're given. Okay. So this is TPX. Okay. Now we go back to the annuity due. So the interest rate was 11%, so that would just be, for the discount, be 1.11 on the bottom. And now we're going to look at P75. So T here is 1. So that'll be 76, 1.2 minus 75 to 1.2. Okay, plus, we want to discount it 2 years now. So we have the 0.01. Here t is 2, so 75 plus 2 is 77. And we're going to subtract that from 75. And I should go an extra step here, because what I'm really doing is this. And then we just close the parentheses. So all we have to do is just plug it in the calculator, and we end up getting 264.22. That's the final answer.